Yes. Yeah. Yeah. Good evening, all. Right. So we had a session right previously, right? I was just briefing you about what is big data, why Hadoop and Spark, drawbacks with the current databases, advantage of Hadoop and Spark, right? The Hadoop and Spark job market, right? And PySpark. So here Hadoop is meant for two things. Hadoop is meant for both storage and for processing. Hadoop is meant for storing as well as processing. Any technology performs storage or processing, but Hadoop performs both storage and processing. For storage, does it use any database? No, databases has got some drawbacks. Despite of those drawbacks, still Hadoop doesn't go with databases. It is going with a kind of file system called Hadoop distributed file system. For processing, MapReduce or Spark. Hadoop is meant for batch applications. Hadoop is not for online applications. Online applications means user interactive application. User gives the input, but in batch applications, user doesn't give any input. User non-interactive applications. Credit card statements for millions of customers. Example, right? Generating credit card statements for millions of customers here, user input is nowhere required. But if it booking a movie ticket, user input is required. Making an online transaction, user input is required, right? I was talking about in the previously I was talking about drawbacks with the current databases. Most of the databases are limited storage, no parallel processing. If volume increases, speed decreases. The volume of the data is increasing. Total amount from sales one, total amount from sales two, total amount from sales three. 10 records, 10 lakh records, 10 crore records. Record to record, right? If the volume increasing, if the volume is increasing, speed decreasing, right? Yes. Even if complexity increases, the speed decreases, right? Even if complexity increases, speed decreases. Total amount, the average amount, standard deviation of amount. Here, average amount takes more time, right? As compared with the sum. First, sum to be calculated, next average has to be computed. As compared to this, average amount takes more time. Standard deviation of amount. Standard deviation of amount, right? Lot of internal processing is required. Lot of internal processing is required. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. So these are the major drawbacks, right? With the databases. We've come to this Hadoop advantages, right? Hadoop advantages. Unlimited data storage. Unlimited data can be stored. Unlimited data storage. Horizontally unlimited number of unlimited slaves. Very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured. It's open source. No licensing is required. Commodity hardware. Can run on all the hardwares. Doesn't mean that it should have highly configured, right? It can run on any heavy hardware configuration. Why databases like Oracle cannot support unlimited storage? Even databases can go with multiple systems or multiple slaves. Talk about these databases and max limit on the number of slaves. Oracle can go with a maximum 256 nodes for storing its data. MySQL with 54. MySQL Express with 256. SQL Server 256. DB to 256. Teradata can go with a maximum 512 nodes. Teradata, Netija, and Vertica, they're used for data warehouse, right? Specialized databases used for data warehouse purpose. So all these three 512 nodes. But these two, Teradata and Netija, currently they are going with 1024 nodes for storing its data. So here, but there is no limit on the number of slaves that Hadoop can have, right? Yahoo, when first time implemented Hadoop, went with 4,000 nodes for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. Systems, nodes means systems. Facebook, when first time implemented Hadoop, Facebook, when first time implemented Hadoop, went with 8,000 nodes for storing its data. Currently, Facebook going with 52,000 nodes for storing its data. So if you see the speed, if you see the speeding, this is what Hadoop is prevent storage point of view and even processing point of view. If we talk, it has taken a table. Yahoo has taken a table to check the speed of different databases. Has taken a table of 100 TB consisting of 1024 columns. Task sorting based on 16 columns. Time taken, right? Oracle has taken nearly 3.5 days to process. MySQL, right? It has taken nearly 6 days. Teradata, like 4.5 hours. Netija, 3 hours. Hadoop, 3.4 minutes. Latest version of Hadoop has just taken 1.2 minutes. Okay, so these have taken days of time. These have taken hours of time, but Hadoop has taken minutes of time. But even Hadoop has got very high speed, right? Hadoop has got very high speed. But Spark is 100 times faster than Hadoop. Spark is 100 times faster than Hadoop. See the speed of Spark. Already Hadoop has got very high speed where it has taken only minutes of time. But Spark is 100 times faster. So very high speed processing, right? Both Hadoop and Spark commonly used together, right? Yes. So now, how exactly data stored? See how exactly. See, before that, I was discussing about architecture, right? If you observe, Hadoop was just talking about this. Hadoop doesn't follow client server. Hadoop doesn't follow client server architecture. It doesn't follow client server architecture. Hadoop follows master slave architecture. Master slave architecture. It follows master slave. Single master, multiple slaves architecture. Hadoop cluster means group of nodes, group of nodes means systems connected in a network, connected in a network. Hadoop cluster means group of nodes, systems connected in a network. There are two types of nodes, master node, slave node. There are two types of nodes, master node and slave node. Master node, we call it as a name node. Slave node in Hadoop terminology like a data node. Master node responsibilities, yes. Task assignment, load balancing, assigning tasks to the slave systems. The task should be equally given to all the slaves. If fault tolerance means if any systems fails, multiple tasks are executed by multiple systems parallelly. If any one slave, if any one slave fails, then the task of it has to be assigned to any of the other slaves. Health monitoring. Health monitoring, right? Yes. Okay. Slave node responsibilities, store data and processing. Slave node, okay, just observe 10 months. Hadoop follows master and slave architecture, single master and multiple slaves. S1, S2, S3 up to Sn. So this is master, these are slaves. Master node. This is slave node. Slave nodes we call it as data nodes. Means data stored within the slaves, data processed by slaves. Means if you talk about any file f1.txt, this we call it as a cluster. Group of systems connected in a network. Group of systems connected in a network. Two types of nodes, master node, slave node. Group of nodes connected in a network. One is master, remaining all are slaves or data nodes. So f1.txt. You have got a file f1.txt. We have got f1.txt. The file, for example, each system capacity 1 TB, 1 TB, 1 TB, 1 TB. This file size is 2 TB. It cannot fit into any of the slave systems. It has to be divided into smaller parts and has to be distributed across multiple systems. The advantage we see is distributed. Data is distributed across multiple systems and data is processed by multiple systems. Data stored across multiple systems. Data processed by multiple systems parallelly. Data stored across multiple systems and data processed by multiple systems parallelly. Distributed storage and parallel processing. Fine. How exactly the data stored and processed, right? How exactly the data stored and processed in Hadoop. In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file is again subdivided into subdivided. File is again subdivided into blocks. File is again subdivided into blocks. Blocks are distributed. Multiple slave nodes and are processed. Blocks are distributed across multiple slave nodes and are processed. Default block size. Default block size is 64 MB. In latest versions, it is 128 MB. Default block size 64 MB. In latest versions, it is 128 MB. For example, I got f1.txt. Size is 200 MB. f1.txt size is 200 MB. Assume it is some banking data. It has got some banking data. Default block size. Assume that default block size is 64 MB. Default block size 64 MB. Number of blocks into how many blocks? Number of blocks. File size by default block. File size by default block size. So f1.txt size is 200 MB. It has got banking data, right? Default block size 64 MB. Number of blocks. File size by default block size. File size is what? 200, 200 by 64. 200 by 64 means like approximately, right, 4 blocks. Approximately 4 blocks. B1, B2 means 64, 64, 64. 192 you will get plus 8 MB. Fourth block. Fourth block has got 8 MB. B2, B1, B2, observe here, B3. B4. B1 block, B1 block 64 MB. B1 block has got 64 MB. B1 block 64 MB. B2 block also like 64 MB. B3 block also 64 MB is stored. In B4 also 64 MB. Sorry, in B4 8 MB only. 8 MB only. 64, 64, 64 means 192. 8 MB only in the means 56 MB free here. 56 MB free. I got F2 dot same thing. Same thing I'll copy. There's one more file. Assume you got one more file. F2.txt. Size exactly 192. Assume that you got some telegram there. Default block size 64. Number of blocks 192 by 64. Exactly 3 blocks. So here B5, B7, B5 has got 64 numbers. So these are stored in which system? System start system 1. This in system 2. This in system 3. B5, B6, B7 also they are storing 64 MB, 64 MB, 64 MB. 64 MB in this, 64 MB in this, 64 MB in this. So here my query is 56 MB is free here. But this B5 data not stored in this before. 56 is free. Then 56 by B5 data not stored in B4. Retrieving f1.txt. Retrieving f1.txt is combining this B1 plus B2 plus B6 B4. B1 plus B2 plus B3 plus B4. retrieving f1.txt, right? Okay. If I data, assume that if we data, so before, assume if we data, so this if we if I just before, for example, 64, 64, 64, 64 plus 8 plus 80 plus 56 MB, that equal to 256 MB. Two 56 MB, but actual file size is 200 MB. Wrong computation. When we retrieved, when we retrieved f1.txt, when we retrieved f1.txt, design principles with design principles with respect to HDFS blocks. HDFS blocks. Design principles with respect to HDFS blocks. Every file should have every file should have dedicated number of blocks. Dedicated number of blocks. Every file should have dedicated number of blocks. Means file one should have its own blocks, F should have its own blocks. In a single block, no two files data. In a single block, right? No files data to be stored. In a single block, no two files data to be stored. Every file should have dedicated number of blocks. Every block in a single block, no file data to be stored. Every block should have every block will have equal volume. Every block will have equal volume except the last block. Every file should have dedicated number of blocks. A single block or no files data to store. Every block will have equal volume except the last block. Except the last block means everything have equal value. 64, 64, 64. Only the last block will have less. Configuring block size. Configuring block size. Configuring means increasing or decreasing. Increasing or decreasing the block size. Go to the install directory. Go to HADOOP install directory. That HD, we'll see one file with the name hdfs-site.xml. One XML file will see. It's an empty file you will see. Open it's an empty file. Open this file and configure the following. Open this file and configure it. Go to the household directory. You see HFN side, open this file and configure the following. It's an empty file. So just file means your configuration opening this opening. This we say it as opening / configuration. This we can closing the configuration. That property and property. Within this property, right? Property dfs.block.size. dfs.block.size / name value for this. So by default it is 64 MB, 64 120. By default, if you're not specifying anything, it takes 28 MB. If you want to keep 50 MB, 50 MB by default box, or 100 MB, or 150 MB, or 30 MB, whatever you want to keep, you can keep it. You can configure your own blocks. Your file will be divided, your data file will be divided into fixed size. Each size will be 50 MB or 100 MB. For example, you got 1 GB file, like 10 MB file, 1024. Will be 100 11 blocks you will get. This way you can also set your own block size, right? I'm going to discuss 4 cases. After I'm going to discuss 4 cases.
I mean, if we decrease, if we place size is 128, the data pass. If we place the example one block size is 200 MB like that, so the default 128, we can increase also saying that. Less blocks means it will fast fetching anything difference will come.
Yes, I was just about to ask the same query. So the
Okay.
same query.
Okay.
Disadvantage, yes. Having a big default block size. Or smaller. Smaller default block size. Try to answer anyone as per knowledge. Which is advantages. I'm saying you can set your block size. So if you are setting bigger default block size, not small.
It depends on data. So if you have used data, you can split it, right? So based on that smaller default.
Okay. Just observe. Example, I got f1.txt, f1.txt, 1000 MB. I'm taking default block size. Default block size taken as 500 MB. 500 MB. How many blocks?
2 blocks we can.
2 blocks. Advantage, if you have 40 nodes, that data is stored, data in only 2 nodes, and data processed by 2 nodes only. Data processed by 2 nodes only. but lesser speed. If it was default block size, at least around 10 systems should be running parallel. Right? So lesser speed, just an example. You brought building concept, you brought 40 labors. In that you are giving work to only 2 labors. 30 labors are free, right? If you are given that work to all the labors, should have been high speed, you should have got high speed, right? What speed? So that means just told if you take bigger default block size, data want to be distributed on all systems. Only less number of systems the data gets distributed, only less number of slaves will be. Yes, rapidly. You want that much of speed, right? Yes. And what happens if you take less block size? Is it advantage? Hmm. Okay. For example, this example, TST, 100 MB only. Default black size, 10 10. Hmm. No, 10 is advantage. Is it advantages, right? Already very small file, very small, and again dividing into small parts, dividing into small parts, distributing across multiple systems, and processing, and coming the result, and later combining the results, and later finding the result is a time-taking process. So the block size should not be too big or too small. So the block size should not be too big or small. That's the reason Hadoop has given default block size 128. Still, okay, as you say, right? Depending upon the data, so you can increase your place. Depending upon your cluster capacity, depending upon the incoming data, you can also increase or increase that speed you are expecting, right? So you cannot have much big or too much. Okay, so for block size. So you can say yes. Now I'm going to discuss 4 cases, right?
So this is small doubt. If the file size is less than the block size means, then how that's your means?
I'm just going to say this.
Okay. Based on kernel reports, what I asked.
So here I'm going to discuss the cases. In case one. Case one is number of blocks equal to number of slaves. What was that? What was that you asked? If the block size?
The block size default, so the file less than block size means how we divided into the block. Like you go to the first block on the it also
Only one block. If it
one block. Yeah.
has got 64 MB, if it has got 8 MB, the 8 MB will be stored, remaining will be free.
Okay. Yeah, that only so. Sure.
Number of chips. For example, think that you got 4 blocks, 4 slave systems. Number of blocks means B1, B2, B3, B4, B4. You got 4 blocks. Slaves like S1, S2, S3, S4. How exactly the data storage and processed you can see here. How exactly the data stored and processed.
Sir, I have a small look here. Sir, each block, the data transfer data, it's fully loaded, or something will be kept for storage.
Each block again.
If it has the 64 data, 64 storage, sir. So 100 MB's data is coming to the P1. Is fully loaded 61 MB or something, some storage will be kept like
Very, very simple. Very simple, right? Okay. You got 10 blocks are there. 10 blocks are there. 64 MB. Assume that your file is divided into 10 blocks.
Okay.
4 MB blocks. F1.txt. F1.txt, right? 10 blocks. You have got how many systems? 5 systems are there.
Yes.
Right? 1, 4, please begin with 5 systems are there. This system 1, system 2, system 4, system 5. But 10 blocks are, how these 10 blocks are going to be stored into this 5 systems? First, B1, B2, B1, B2, B3, B4, B5. Again, B6, B7, B8, B9, B10. Means each system storing 2 blocks. Equal value. Only the B10 will have the less value. Anytime you see whatever the file size, only the last block will have that less size. B1, B2, B3, B4. But only 2 systems. In one files will be stored, in 5 blocks will be stored. Means all will have equal volume except the last one will have less value. So depends upon number of systems, the blocks are distributed. Means what might be file size. Whatever you what is what, just specifying the block size. Automatic is going to take itself. Means it is going to divide into blocks and the block is going to distribute across multiple systems. But everything taken care by the Hadoop website. So whatever the size it is, divides into blocks and stored across it. Because you have already stored, you're maintaining a cluster with multiple systems. So will be distributed across. But the difference that what I'm going to discuss next. We'll discuss 3 more. If the number of blocks equal to number of slaves, very high speed you see. Very high speed. For example, f1.txt size 230 MB. Default block size 64. Number of blocks how many? 230 by 64 means 4 blocks. How these 4 blocks are? 4 blocks are B1, B2, B3, B1, B2, B3, B4. How these blocks stored across 4 systems? 4 blocks. Think that each block of 10 lakh records, 10 lakh records, 10 lakh records. This B4 has got some 5 records. How these blocks are multiple systems? This is the master node. These are the slave nodes. How many slaves? 4. 4 slaves. This is one slave. This is one slave. This is one slave. 4 slaves. S1, S2, S3, S4. So B1 stored, B2 stored here, B3 stored here. Data distributed. Data is divided into blocks. These blocks are stored. right? Yes. So this is the master node. This is the master node. These are data nodes, slave nodes. Slave we call it as data nodes, right? Master node. Within the master node, we say it as name node. We have got a name node. Name node maintains metadata. Metadata means data about data. It won't store data, but data about data. Data about data. F1.txt divided how many blocks? B1, B2, B3, B4. Where B1 is in S1, where B2 in S2, where B3 in S3, where B4 in S4, right? This information, this everything will be stored within this name node. The node stores the metadata information. This is how the data is stored. The 4 blocks. The blocks are distributed systems. Now data processing observe. Data processing. Job to process F1.txt file. Always will be divided into tasks. Job always divided into tasks. Number of tasks. W divided into tasks. Number of equal to number of unique blocks. Number of blocks how many? Number of blocks how many? 4 blocks. 4 blocks, 4 tasks. 4 tasks. Job to process F1.txt. Yes. T1, T2, T3, T4. T1 task is for what? B1. For executing B1 10 lakh records. T2 task is for executing B2. T3 is for B3. T4 is for B4. Who should execute this T1 task? Which system has to execute this task? As B1 is sent in S1, S1 only should execute. Who should execute this T2 task? Which system has to execute? Hello? T2 task should execute by T2, B2. Executing B2 is present in slave to S2 execute. Now that S1, S2, this one, S4. Means here 4 tasks. Means T1, T2, T3, T4 are executed by 4 slaves. S1, S2, S3, S4. No task is in the waiting state or executed parallelly. That's why very high speed. No, none of the task is in the waiting state. But if you have this case 2, some task will be in waiting. That's why case 2, if you observe number of blocks are more, slaves are less. In this case, less speed. Less how 4 blocks are there, 2 slaves are there. So B1, B2, B4, 4 blocks. How many slaves? 2 slaves. S1, S2. F1.txt. F1.txt. 230 MB. Default block size. Assume 64 MB. Number of blocks. 230 by 64. 4 blocks. 4 blocks means B1, B2, B3, B4. How is block stored across this? Master and multiple 2 slaves only. Think that less number of slaves. How this data is distributed? This way class within the okay. Here B1 again B3, B4. Yes. This one is S2. Here F1.txt divided into 4 blocks. B1, B2, B3, B4. Where this within this master node is a node maintains metadata. Metadata means data about data. B1 by S1, B2 by S2, B again S1, B4 again S2. This is how the data is distributed across multiple systems. That is fine. But if you talk about this data processing, right? If you talk about a job to process F1.txt, job process F1.txt divided into tasks. Number of tasks always number depends on blocks. How many unique blocks here? I am using the 4 blocks, right? 4 blocks means number of tasks equal to 4 tasks. Job to process F1.txt divided into 4 tasks. T1, T2, T3, T4. T1 for executing V1, T2 for executing V2, T3 for executing V3, T4 for executing V4. Who should execute this T1? Who should execute? Which system has to execute this T1? Hello?
Yeah, it's assigned to B1, right? Yes, sir. First B1 only T1 will
System T2 by
System.
T2 means executing V2 has to complete. This V2 is present in S2, so S2 only to execute on this side S1. D3 for executing D3, D3 stored in S1 only. B4 is present in S2.
So is it alternative, sir?
Not alternative. If B1, B2 is stored here, then the two blocks by S1. D3, B4 is stored in S1, right? So whatever it is, 4 blocks are there, 2 stored in this, S1 storing the 2 blocks, S1 execute 2 tasks, S1 execute 2 tasks. Simple, right? Take level example. 4 tasks are there, only 2 level persons are there. If 4 tasks are there, only 2 persons are there. You'll assign 2 tasks to this person, you'll assign 2 tasks to this person, whatever it is. 2 tasks here. Two tasks. Means when here only one task can be executed. When T1 is executing, T3 will be in the waiting state here. When T2 is executing, T4 will be in the waiting state. Means only 2 tasks are executed parallelly. Remaining 2 are in the waiting. Think that 40 tasks, 20 slaves only are. These 20 slaves can execute 20 tasks parallelly. Remaining 20 will be waiting state. Means once this 20 tasks got completed, the next 20 tasks will execute. Here also, once T1 is complete execution finished, next will execute T3. Means some tasks are in the waiting. That's why I'm saying less. In the case 3, if you observe this case, right, more blocks, only one slave. More blocks, only one slave. More blocks means blocks. Only one son. B1, B2, B3, B4. Only one slave son. B1, B2, B3, B4, only one slave. 4 blocks, only one slave. Means one master, one slave. S1. Here only all the slaves B1, B2, B3, B4. This master node name node stores the metadata for txt into 4. B1, B2, B3, B4. B1 by S1 only, B2 also by S1, B3 also by S1, B4 also by S1. Even if you talk about the data processing, job to process f1.txt in the tasks, number of blocks. Only 4 blocks means 4 tasks. 4 tasks means T1, T2, T3, T4. These 4 tasks should be executed by S1 only, S1 only, S1 only, S1 only, sequentially, one after the other. No parallel processing here. 4 tasks executed by 4